I'll go ahead and open my cam tiles. We'll build up our process right here. We'll grab the tool we want to use. We'll start by cutting the flats, so I'll grab the 5/8 end mill and a contour process and put it on top. When I put those two icons together, this dialog opens up. I'll start in the upper left-hand corner. I'll set my speeds and feeds. I'll go with a 10th line in and out and a 0.3 radius in and out. I'll come back and set number of extra offsets later. I'll leave it at 0 for now. Up here in this schematic, we define our Z depths. Let's look at the drawing. We're cutting on this diameter here. It has a diameter of 3.8 inch. Our wrench flat is a total of 3 inches. So our top Z level will be 1.9. Our bottom Z level, 1.5. I'll make our entry-exit clearances above my top Z level, so I'll set them to 2. We have a total cut depth of 0.4. I'll cut it in two 0.2 Z steps. I'll close the dialog box off and pick this end of the line. Whatever end you click on, the tool will start from that end. So this determines whether we are climb or conventional milling. If I click here, the tool will climb mill. This machining marker does 3 things. On which side of the geometry is the tool going to travel? I'll pick on this circle. The blue arrow is the direction of cut. It is already set. And thirdly, these white and black markers tell the system where the toolpath starts and stops. I'll hit the Do It button. I'll turn on our simulation. It's that 6th icon down the right-hand column. You can see it's a pretty wide cut. It's well over half the diameter of the tool. We're cutting this in 2 Z steps. We may want the tool to start cutting out here and take 2 extra passes. I'll go back to our process dialog and put 1 here. I'll make the extra step over approximately the radius of the tool. I'll say 0.3 and hit redo. Let's have a look. I'll hit rewind and single block it. You can see the first cut is much more manageable. Now we're going to rotate this toolpath around to cut the flat on the other side. I'll go to the Rotate tab, duplicate it once over 180 degrees, and hit Redo. Now the toolpath will cut both sides. Let's have a closer look at this toolpath. You'll notice when we created this toolpath, the 2 op tiles appeared. This is because we used number of extra offsets feature. When we run the simulation, the tool cuts at A0, then rotates to cut at A180, then goes back to A0 and cuts again, and finally back to 180 again. Obviously, that is not as streamlined as it could be. Let's eliminate the extra rotation here. Let's redo this toolpath so that it only cuts at A0. I'll double click on the op tiles and open the process dialog. I'll go to the Rotate tab and remove this and hit Redo. You'll see now that the tool is only cutting at A0. Let's create a new operation which only cuts at A180. I'll open the process dialog and go to the Rotate tab. I won't use duplicate and rotate, but I'll key in 180 here and click on the Do It button. You'll see by hitting on the Do It button, 2 new operations are created in the op list. Let's run the simulation again. You'll see that it cuts the whole A0 face and then rotates and cuts the A180 face. Let's toolpath our holes. I'm going to clear out my process list and deselect any operation I may have selected. Let's start with center drilling and drilling through. I'm going to grab the number 3 center drill and drag it down to process tile number 1 and a holes process. I'm going to feed in, wrap it out. I'm going to set my speeds and feeds. Here's where we define our Z depths. Before we fill this out, let's have a look at our drawing. We're drilling this hole. It's on a diameter of 2.5 inch. We're cutting on the radius, so our top Z level will be half of that. Let's go back to GibbsCAM and key the value here. This is the Z level the material is at before we start cutting. It's always a good idea to set this value first. There's 3 ways to define depth of a drill. There's tip depth, full diameter depth, and if you don't exceed the diameter of the tool, you can determine the depth of the drill by the spot diameter the tool leaves. That's what we'll do here. I'll leave a spot diameter of 0.2 inch. Let's set our entry-exit values to just above the top Z level, 1.35. We have different retract options. We'll select 1.35. I'll close this off. Next, we're going to drill through with the tap drill. Let's grab the tap drill and drag it down to process tile number 2. I'll grab another holes process and put it on top. This time, I'm going to peck chip break. I'm going to set my speeds and feeds. I'm going to peck in 0.1 and retract 0.02. My top Z level is still 1.25. This time, we want to make sure the drill breaks through the ID of the part. We need to know what the ID of the part is here. Let's go back to the drawing. The ID is 1.5. 2 things to remember is that we are cutting on the radius, so I'll have that amount. And second, the full diameter of the tool has to break through the ID. Back to GibbsCAM. This time, we'll use the full diameter depth field. We're going to drill a little deeper to make sure the full diameter breaks through the ID. The radius is 0.75, so we'll drill to 0.7 deep. I'll close the dialog. I'll pick on the point and press Do It. Let's run the simulation and have a look.